Welcome to Lesson 4.2, Comparing and Ordering Rational Numbers. The essential question is how to compare two fractions. A rational number is a number that can be expressed as a ratio of two integers written as a fraction. The denominator cannot be 0. By the way, the word ratio is another word for fraction, so you can kind of think of them as the same. They're just comparing two numbers. Common fractions, terminating and repeating decimals, percents, and integers are all rational numbers. So if you could look at the number bank here, the first number 0.8, that's an example of a terminating decimal. It stops. The second one, 2.2 with a bar of the 2, is an example of a repeating decimal. -1 and 1 and 2/3. That's 1 and 2/3. Okay, so you have an integer, you have a regular number, and then you have what we call it the mixed number. So what we're going to do is we're going to take these numbers in the number bank and we're going to put them in the right spots. Now, rational numbers can be any number that you know. So every single number in that number bank is a rational number. So if you want, you can go ahead and fill this out. We could put 0.8. We could put 2.2 with a bar over it. We could put -1. We could also add some other ones as well. We can add 0. Let's see, we don't have a mixed number, so we can add 1 and 2/3. So basically any number that you know, negative or positive, fraction or decimal, can be a rational number. An integer, that kind of narrows things down. So it excludes decimals and it excludes fractions. So it can only have negative and positive numbers. So for example, -3 and say +1 and say 0. And notice I don't have any fractions or decimals. Now once you get down to the very center where it's whole numbers, now we are excluding the negatives and we only have positive numbers. So we have like 2, we have 5, and we also have 0. Alright, so down here it says identify each category the following numbers are in: rational number, integers, and or whole numbers. So looking at -5. Now -5, we definitely know that it's a rational number. And I'm just going to put the abbreviation for R meaning rational. -5 is also an integer because it's not a fraction and it's also not a decimal. So I can put integer. However, it cannot be a whole number because there is that negative, so I'm going to leave it there. Letter B, 0.414141. So this is a repeating decimal. So it has to be a rational number because all numbers that we know right now are rational. However, it cannot be an integer or a whole number because it is a repeating decimal. It's a decimal period. And our last one, 239. So we know that that's definitely a rational. It's an integer because it's not a fraction or a decimal. And it's a whole number because it is not a negative. Turn the page. Make sure you have these notes in front of you. Example. Fill in the blank with less than, greater than, or equal to make 7/12 or 18 into a true sentence. So first off, we notice that these fractions, they have different denominators. One is 12 and one is 18. We have to make sure that they have the same one. So what we're going to do is we are going to try to find the LCM for these two numbers of 12 and 18. Now what I like to do is I like to start with 18 and then and whatever I get for my multiple, I'm just going to match it with 12 to see if it goes in. So let's start. 18 times 1 equals to 18. And I know that 18 does not go into 12 evenly. So I'm going to try the next one. 18 times 2 is 36. And I think to myself, does that go into 12? It does. That's 12 times 3. So I know that 36 is my lowest common multiple. So I'm going to write my fractions here. And I'm going to go ahead and change the 12 into a 36. And I know that 12 times 3 equals to 36, so I'm going to multiply this by 3, and I have 21. And then this will be 36 as well, and I think to myself, 18 times what equals to 36? That would be times 2. So multiply by 2 up here, and I'll have 16. Now it's very clear to see which one is bigger. It's going to be greater than. In Mr. Huang's class, 20% of students own roller skates. In Mrs. Trevino's class, 5 out of 29 students own roller skates. In which class does a greater fraction of students own roller skates? Okay, so let's see. In Mr. Huang's class, 20% of students own roller skates, 5 out of 29. Okay, so we just got to see which one's bigger. So we have two different measurements here. We have one that's a percent, so that's 20%. And we have one that's a fraction. So we either have to change both of them into percent or both of them into fractions. For me, so I'm going to go ahead and change the 5 over 29 into a decimal, and then that'll give me my fraction. So I'm going to remember that it's in and out. So I'm going to put the 5 on the inside and the 29 on the outside. Okay. So I know that 29 goes in 51 time, and that's going to be 29. And I'm going to subtract that, and that's going to give me 21. I'm going to drop the 0 down. And, don't forget about this decimal. So 29 goes into 2 tens 7 times, and that's going to give me 203. Now, you don't actually have to finish this problem because you can see really quickly that 7.17 is just 17%. So we know that 20% will have to be the bigger one. Comparing rational numbers. A common denominator is a common multiple of the denominators of two or more fractions. The least common denominator or LCD, some people call it LCM, they're the same thing, is the LCM or least common multiple of the denominators. You can use LCD or LCM, whatever you were taught, to compare fractions. Example 1, fill in the blank with less than, greater than, or equal to make negative 1 and 5 over 6 and negative 1 over 6. Which one is a true sentence? Now, because they both have negative 1, I'm just going to kind of move them off to the side, and I'm really just going to be comparing 5 over 6 and 1 over 6, okay? Now, I know that when it's negatives, because whatever one is closer to 0 is basically going to be the one that's bigger. Now, if I were to put this on a number line, negative 1 and 1 over 6 would come first, and negative 1 and 5 over 6 would come second. So, according to my number line, this one would be the bigger one. I don't need to worry about the LCM or LCD because, as you can see, both of them have an LCD or LCM of 6, so it makes it easy for me. Ordering rational numbers. You can order rational numbers using place value. Example, order the set 3.44 pi, 3.14, 3.4 from least to greatest. Okay, so we have 3.44. I'm going to do some conversions here. I know that pi is 3.14, but I can't really put that because of the one next to it. So if I go on my calculator and I type it in, the next number is actually a 5. So 3.1415, and then there's a 9 and so forth. Okay, so 3.14 stays the same, and then we just have to remember that 3.44 is 3.4, and it just keeps going. They're all 4s. Okay, so least to greatest, the smallest would have to be 3.14. And it really helps after you do it just to cross out the ones you've done. And then the next one I would probably say would be pi, because pi has a 5 after it. Then the next one would be 3.44. And then the very last one would be 3.4 because they have way more 4s after that. Now, keep in mind that I did change everything back to its original form, so that's how your answer should be as well. Go ahead and do the got it problems down below letter F all the way to letter D. Keep in mind when you're comparing fractions, make sure that you are paying attention to the denominators, just to point out these denominators are not the same. So you will need to use your LCM and LCD to find them. We'll go over the answers tomorrow in class.